Hey guys, my name's Eric, and this is Mark.
Hey.
We're going to talk to you guys a little bit about what we built and what Tulip is all about generally. So we're going to jump right into it with a couple of just quick observations. First, before we get started into specific solutions, I want to just make a broad observation about manufacturing operations. And this is that, one, they're complex, and two, they're dynamic environments. They change over time. I would argue this is becoming more and not less true. And yet, I don't know how many hundreds and thousands of factories have been on at this point, but whenever we go to a new facility, this is typically what we see. Some combination of legacy infrastructure, sort of a patchwork of different point solutions, kind of playing whack-a-mole with the different problems on the shop floor, and a bunch of paper processes because engineers will not be stopped, and if you don't give them the technology, they'll find a way to get it done, and they'll use what they have available to do it. So I want to just make a couple of observations. The first is that when you get into any of these particular challenges on the shop floor, we're going to talk about a couple of them today. I want to observe, these are not isolated, distinct, neatly segmented use cases here. They are inextricably interconnected and overlapping. Maybe you've got a production visibility issue over here. Maybe your orders are late over there. Maybe you've got a line down and you don't know, not yet anyway. And the people who are at that line, they've got the information, but nobody else. The people who need to be involved to help solve that problem, it's not accessible to them yet. So when we think about this mosaic of use cases and challenges that you're going to find in any factory that you go to, we don't think about it as this kind of siloed set of use cases for technology. We think about this as this quilt, this mosaic, this patchwork of interconnected and overlapping use cases. So, for example, if you were to start with just addressing production visibility and nothing else, at some point here, you're going to start to cross that line into, am I doing production tracking? Or am I doing work instructions? And if I'm doing work instructions and I'm scanning my work order in, I'm performing my operation, I'm scanning it out, it's going to the next line, well, am I also going to be doing a quality inspection at this station? And at what point does it become more of a quality application? Or if the line goes down, do I want to notify somebody? So at what point is it an and-on application and not a work instruction or production visibility application? I would argue that this is the nature of the operations and of the use cases in the factories that are producing our goods and services. Furthermore, each of these use cases, they don't live in an island. Like all of them together don't live in an island. The data that you need, the perspective you need to solve any of these problems, that information lives probably, or some dependency exists somewhere elsewhere within the IT infrastructure, whether it's work order information or inventory information from an ERP, whether it's a quality management system, so on and so forth. So I'm going to give you a little bit of an overview on Tulip, and then we're going to get right into what we've built. So Tulip is a composable frontline operations platform, and we see Tulip as being the foundation for all the different use cases that I've just described here. A couple of things that make the Tulip platform what it is. The first, it's no code. That means you don't need a background in software development to be able to build applications very quickly, as you'll see here pretty soon. The second, and this is critical, it's an open platform. So we believe in free exchange of data. If we need information from some other system, we better be able to get it. And if you need something out of Tulip, you can rest assured it's going to be available via API, via connectors, via several different mechanisms. The third is that once you have all of these applications and these use cases deployed across the shop floor, connected to the physical and digital infrastructure, you also want to do something with that information. So you want to be able to, it's an analytics capability as well. You want to actually go from raw data collection to actionable insight that you can do something with. And then last but not least, you don't want to get started from scratch. So you want to get started with your templates, with your best practices, with your apps that you can import, whether it be an app suite, whether it be a standard connector to SAP, so on and so forth. So the way that you deploy these use cases is you get started small, you solve the core of the problem, and then in an agile way, you continue to take on scope, you adapt the use cases as needed based on feedback from the shop floor, and then you have this kind of emergent capability or this emergent system that comes up from the as you take on all these different use cases. So that's what we're going to show you. But what you're going to see today is not the whole of this thing. This is just the beginning. We're going to take some of those use cases, and we're going to show you how we responded to the challenge and what we built. But I want to emphasize that, again, this isn't the end. This is just the beginning. So with that, I mean, I think I'm going to let Mark prove it, yeah?
Yeah, thank you. Hey everybody, my name is Mark Friedman. My background's in manufacturing, so I'm a guy who likes to go on shop floors. I've spent 15 years in manufacturing. I'm kind of like a customer of Tulip who works at Tulip. And one of my favorite things is Kaizen, or continuous improvement. If you talk to the Toyota guys here, I talked to them for a while. I love Kaizen and continuous improvement. And to me, Tulip is basically like the ultimate Kaizen tool, because I'm not a programmer. I've never built an iOS app, but I've built hundreds or thousands or whatever of apps in Tulip, and I'm able to use technology or leverage technology that otherwise just isn't available to me. So for that reason, I can do it quickly too. So this whole thing was built in like 3.5 days or so. And when we got invited to come here, I was excited at the challenge, because solving real problems at factories is literally my favorite thing to do. So I'll show you how we approached it. This is the packaging solutions provider that is the customer here. If they're here, thank you for letting us take a window into your operation. We looked into the data. We talked to some people. Normally, I would go to the shop floor. We would go to the shop floor and talk to the people there. We weren't allowed to do that. But we did have access to the data and could ask some questions. And we realized that it's absolutely critical, like Walker said in the keynote, that these presses are the bottleneck, of the pace setting operation. They have to be running all the time. When we looked at the data, we saw that there's 54% availability across all work centers. And that's in 2023 data that was available to us. But those press machines aren't running as often as they could be running or should be running. We also saw that of the schedule they have to run to, there was 90 schedule exceptions in December of 24. So more than 3 times a day, we're basically saying we're not going to do the schedule. So this is where we wanted to focus on, and we thought that, Tulip likes to focus on augmenting the human and the actual workflows happening on the shop floor. And to do that, we thought, let's bring the UNS to the human and kind of give them this cyborg-like situational awareness of how the machines are running and what they can do, as well as put the human in the UNS and give that data so that other people can take advantage of that information. So here's a video we found of the operation. You can see the press machine there and the material handler, and we figured that person has a pretty tough job. What can we do to help that person in their workflows? So some of the things we saw in the data was that for the reason they pulled the jobs from the press machines was that the approval wasn't ready. They need to check that the work orders are ready before they run them, and they weren't ready. So they had to pull the job because they ran out of material, or because it was missing print information, or any of these reasons. So we're going to talk about what it must be like in this space. This is kind of a story, and it's a little bit like Murphy's Law. So anything that can go wrong in manufacturing does go wrong. So hopefully this is helpful to explain our view here. So there's 3 press machines. These machines are fed by raw materials or film, and they have to run according to a schedule. So the first thing we wanted to do was put an application in front of the press terminals so they could indicate which job they chose to run. And then we needed to somehow let the material handler know that we're going to run this job. We need to get material for it. So we have a shortage immediately, and the material handler has to go make sure they have that. So the material handler is going to go and grab that information, grab the film and bring it to the press, and then we can read from the UNS onto the terminal all what's happening with the press, the OEE, the line feed, everything that's going on there we can know, but eventually it's going to run out. So that's a problem. It's not that they're going to just bring one film, they have to keep it continuously fed with film. So they need to bring more film. So what we decided is we want to implement into the UNS this idea of like a queue, a film queue of the pick list. We have to make sure that they know that it's not okay just to have that one thing there. They actually have to have something on deck all the time. So we added that into the system. And then the terminal operator now has to pick what the job's going to be, right? Because it might be the same job that they're running, but it could be that they have to pick a new job. They're going to run out of this one. And when they pick that job, we also found that they skipped the schedule. If they skip the schedule, a supervisor has to know that a schedule is skipped. So this is the kind of stuff that happens in manufacturing. This is what makes it challenging and why I love this stuff. So we had to keep track of what was skipped. So now the material handler has to figure out the next job, put it in queue. But what we saw was that it might be the case that they brought that order over, but something wasn't complete. The print was missing or whatever. So the press operator has to be able to indicate, actually, that's an issue. Supervisor or planner has to deal with that, and we need to return that because someone else might need that, and that might mean another machine is down. So they pick a different job, and then the press handler or the material handler is going to go and grab that, bring it back, and then they're going to look for material. But what else did we see? we saw that they don't always find the material they're looking for. So they have to be able to tell the press terminal that, wait a minute, what you chose actually is a shortage, and you need to pick something different. And this is the challenge we decided to fix because we wanted to fix availability. The presses have to always run. So it's not just one person running one press machine. It's actually a bunch of people servicing a bunch of press machines and laminators and slip machines and pack machines. And this whole thing is why it's fun. And so having fun, I guess we knocked that off. This is how that works. So I'm going to show you what we built. And like Eric said, this is just one. Normally we would have built this and then with them there and talked with them, but we just had this one iteration. So we built a dashboard, we built a supervisor app to receive those actions, we built a press terminal, and a material handler app. And I'm going to show you how those work now. And if you want to see more detail, we don't have much time on here. Come to our booth, we'll show you all kinds of stuff. So just to give you a little bit of awareness of what you're looking at here, this is the press terminal app. This is running at the press, at each press. Behind here, I have another app, which is the material handler app. I'll show you that in a second. And then in the far background is our topic in the namespace. You can see, as per convenience, you can see kind of what we're updating and why. So in this terminal app, on the top left, this is all information from the UNS. We can see that it's completed, and as more rolls come through, we're going to see that this is going to move. As more film gets used, we'll see that move through. We'll see the state of the machine, and all this stuff is drag and drop, right? And we'll get into that a little bit more. Over here is OEE. We actually pulled this from Aviva because I like their numbers better. So we pulled this one from Aviva. Thank you, Aviva. And then this is coming from the MySQL database. This is the schedule. And I can override this. I can say, hey, I'm going to raise an alert. It's going to be a safety issue. And you'll notice here in the UNS that updated. So I can resolve this alert. I can talk to Frontline Copilot and ask about historically what were the reasons for this, but we won't get into that. We can do that at our booth if you want to. So we said we needed to get this next order picked, right? So I'm going to pick this order here, view the work order, and I can see here I'm pulling in the checks. So we could have dived into this use case, but we decided not to. But here's being pulled from the database. We're seeing all this information. We're going to add this to the job queue. And you'll notice that as it gets added, we see the next order gets picked up here in the UNS. We see all of these new requests getting created from a pick list we generated in a bill of materials, and we see that we skipped these. So this is a problem, and if I switch over to the supervisor app, you'll see that that's something that we're working on. I'm not going to show you that. I can show you at the booth if you want to. I'm going to stick with this story. So over in the material handler, I see I have these 3 machines, and making it really simple for them, because they're on a forklift, they're running around doing all kinds of stuff. I want to make it really obvious. I need to go here to this requested item and put it in progress. And as I do that, you'll see that as me, I'm an active material handler now, so now it's in the UNS. I see all these things update, and over here, this updates as well. So what I'll do is I'll deliver this one, and then I want to pick the next one in line, right? So I'll pick this one and put this one in progress. Now over here, I'll deliver it too. Over here, this person's going to say, okay, it's delivered, but it's missing a print. What do I do? I'm going to click on this one and say, I'm going to remove this from the queue. So that was false ready. And again, this goes over to the supervisor's application. They can see that. And over here, I see I have to return it now. So now they have to pick a new job. And just this kind of communication truly contributes to the lack of availability. And this changes the game for how operations run. So this is the kind of solution we decided we wanted to make. I'm going to choose this one now. And I'll add it to the job queue, and then I'll let the material handler start working on this one. And as they work on this, like I showed in the example, they're gonna say there's a shortage. So we decided this populates the UNS, and now this screen says, whoa, press terminal operator, stop everything. The material handler noticed that there's a shortage. You need to fix this. So this is how this app works. And I can show you other things like the dashboard for the supporting staff to see all of these things that happen. What's the average response time from the material handler? All this stuff goes into the UNS and is available easy for you to deal with. And this is the supervisor application. If you're curious, you can look at this. You can look at your actions, claim actions, and so forth. So this is what we built.
Nailed it. Nailed it, Mark.
Sweet. Who said that?
Walker. Who do you think?
Oh, sweet. Yeah, so that's what we built. I'm going to show you. So, and the way we built that was, thank you, Walker. That makes me feel good. Here's how the app building generally works. This is me building the app when I was starting. I just recorded myself. This is how it works. I'll show you the app editor now. and I'll use this. So this whole thing is drag and drop, right? So, and again, come to the booth, we'll show you all kinds of cool stuff like that. But if I want to drag like a camera widget onto the screen, this is going to show up immediately in my app. And now you can publish versions and all kinds of stuff, but for demonstration, this is development version. So this is, hey.
We do
this is
have
me.
full governance.
Yeah, so that's all good too.
But nobody freak out.
So if I want to do something like when this barcode scanner, like, so how hard is it to write to, how hard is it to do this stuff? How hard is it to write to the UNS? So when this device, which is the barcode scanner, outputs at the station with the barcode appeared, I want to show a message, and you can do all kinds of stuff with this. I could order a pizza literally if I wanted to. But what I will do is show a message, and it'll just say the device output. And then what I'll do, and this is how app editing works. And there's a lot of features I'm not going to show you here. And there's a lot of features we didn't use, but I'm going to run a connector function after that, which is to write to the UNS. The topic will be, badge, and the message will be, it has to be a string, so I'm going to do it like this. Device output. Okay, thank you, HiveMQ. And then when I go over here, I should be able to just put my thing here, and then there it is, the UNS. So that's all it was to do that. It was not so bad. And you can do all kinds of stuff like that with Tulip and more. So how long did this take? We're actually really good on time.
Got plenty of time.
Oh, what else do you guys want to see? So you can do all kinds of fun stuff. So part of this is, we'll take some time to show you some other cool stuff. If you look at the material handler app, and by the way, you don't have to build all this stuff from scratch. There's a full library of content you can download. In fact, I started from a common data model that we have available in our library. But this button here, registering a shortage, all I'm doing as an app builder is saying, change the material request status to shortage. So data manipulation store a value shortage to that table record. And then that's all you have to do here. But if you're like an architect, a lot of people here are architects, and you might say, like, how do I do more complex logic and stuff like that? Automations are awesome. And the way we're doing that is basically when the material rec is updated, so when this table is updated, and this can be on timers, this can be on a change to the UNS, and I'm using a lot of that stuff here, but this logic editor is basically saying, hey, is it completed? Is it shortage? If it's a shortage, create an alert. If it's then post it to the UNS, and then so forth. Or if it's delivered, then I want to go in and remove certain things and loop through stuff. And this is just how you get to do other fun logic stuff in here. But it makes it really easy for the app, because I just, from an app builder perspective, I just have to think about what is that simple thing I want to do. I want to put this order active. If I put that order active, maybe I'm going to have an automation run to update SAP or do something else. So I've found that I'm really only limited by my imagination here, which is why it's really fun. And there's nothing like going to a factory and talking to the people on the shop floor and solving the problems with them. And then when you drag a button on the screen, it shows up on their iPad, and they're like, that's awesome. And it is awesome. So I'll go back to here now. So how long did this take?
Hey, Mark, real quick, I got a question.
Yeah.
Well, number one, this is, how it's supposed to be done, dude. This was literally the vision for ProveIt. This is ridiculous. I would say this. You demonstrated a very detailed knowledge of the process, not just the automation process, the process of making flexible packaging, but actually how this flexible. None of that shit was fake. The data that was coming from Aviva, the OEE data, that was just simulated, generated OEE calculations. However, everything you put on that screen, that's real. I worked at that manufacturer. That all that stuff is real data from them. It shows a detailed understanding of not just what was in the UNS, but also what was in the MES custom and MES Lite databases, which housed a lot of the ERP data. So that is the scheduler function. You clearly were looking at material handling data as well. It demonstrates a really incredible understanding of the underlying data. The question is, how much time did you spend learning the process by analyzing the data before you got started?
I mean, I took Michael Walker, if he's in here.
Hey, Michael Walker, in here? Raise your hand, man.
So I basically, on a Zoom call, had what was effectively like a bright light in his face, asking him questions and interrogating him. And I'm like, what happens at this factory? Tell me exactly. So that was like my Gemba walk. And then after that, eventually when we got access to the database, I just started looking through it like I would look through one factory that I used to work at, and try to figure out, oh, well, this is weird. What do these mean? And then you were really helpful on the Discord. And then after that, I was like, well, I'm going to have to make up some stuff, like the pick list and the bill of material or whatever. So I made that up. And then it was really, what is it like there? And I wish I could have talked to an operator. But
Well, you nailed it. I mean, so Michael Walker is the director of engineering at Intellic. He also is in charge of the ESOP program there. Michael was the second architect at this client. So it was me first. I did the first year and a half. Michael came in and he did the order entry system. He led the art system. He was the architect for 2 years. So it went me and then Michael. So he picked both of our brains on how the operation works. I mean, that image that you put up there, that's the plant floor. I mean, the video that's running, that is the plant floor. That's what it looks like there. But it's the understanding of the data that I'm actually shocked, because you only had 16 weeks, man. I mean, it shows an understanding that like an engineer who's working there for 6 months would take to understand.
We didn't spend long building the thing because it comes together pretty fast, like you saw. And maybe I'll show you one more thing.
If I can just make one quick point. Sometimes people ask, like, why no code? Why should I care? And you're hitting on the key point, right? Because building the app shouldn't be the hard part. Like understanding the process and identifying the right problem to solve, that's where you want to spend your time. And fundamentally, if you're giving the tools to do this and you're making it really easy, but you're putting it in the hands, you're giving this power to the people who know the process, know the people, and know what problems to solve, that's when you get the magic, right?
Well, I can tell you right now, looking at that, and I talk to the client all the time, I would be like, hey, our next conversation needs to be with Tulip, and it needs to be with the material handlers and with the supervisors. I mean, it literally, I would walk away. I'm going to go to Intellic and I'm going to say, hey, listen, Tulip needs to go directly. While they're here, we should drive down to the facility. We need to talk to the material handlers and the supervisors, for real.
Sweet. I would love to talk to them.
They can have
fucking
all
nailed
this
it.
they can have.
You nailed it. I mean, you nailed it.
So the other thing is that, like, it's just and we're going to get into this too, but it's just the beginning of it, because you're not buying this solution. I wouldn't expect any solution to work like immediately out of the box. That one may, I don't know, but what you'll find is that you make adjustments, and then really you want to solve the root cause of the thing. So you'll figure out that of those actions that we removed, why are we getting so many work order checks that are not right? And then you go through there, you're like, oh, you're using an Excel sheet printed out and you're writing on that, and that's how you're, okay, let's build an app for that, and then that goes away. Now availability goes up another 5% or whatever, and then you just keep finding problems. It's fun.
But what's crazy is you got the schedule deviations right. There were 90 schedule deviations in the month of December in 2024. Think about that. 90 schedule deviations, 3 every single day in that facility. You got the number right.
Yeah, there's chaos in the value stream.
Yeah, it's crazy.
It causes a lot of that sort of stuff. And I will show you, some people say like, oh, well, how do you connect? Like what's that like? It's super transparent. Like this is the ProveIt Virtual Factory Online MySQL database, right? And you can have different development, pre-production, whatever versions. But then this is the press schedule, and it's like, this is the SQL I wrote, And I played with this for a little bit, trying to figure out what it was. But you just run this, and in my app, when I go to make an app, and we can show you more in the demo, and we have some time, so I can probably show you. But basically, what you do is, in the press terminal, so I'm in the press terminal here, I can just put a button on the screen and say, run connector function, the database, get the schedule, save it as the schedule. I spelled that wrong, don't judge me. And then you can just display it. So I want to show a table with that schedule right here. And this is how Tulip app editing works. It's pretty, make it a variable, it's this one. Let's say it's a schedule spelled wrong, and then I'll say it's the job jacket, and I want to see the film description or whatever. And then I go over here, I push this button, and there it is. So that's how you do stuff with this. So I'm going to go back to the presentation because we're supposed to say how much this cost. Well, like what you're seeing is just like one solution. You actually bought the capability to do this. So the base is $250 a month per station. So this is, I said 10 stations, so 3 press machines, 4 material handlers, 2 supervisors, a dashboard. That's $2,500 a month on the professional plan. I'm leaving out a ton of features that we didn't really show you at all. There's a lot of features here. And then you have unlimited use cases. So what do you want to solve? What other problems do these people face? So that's how it took approximately 3.5 days. 1 person, 4 apps. That's, oh, okay, yeah. And so I don't know if you want to talk about anything else.
I mean,
but basically, yeah. I mean, this is the capability that you want to empower your team to have. So the bar is the bar to get in is very low. The barrier to entry is low. You can build these things quickly, small apps, and then as the ceiling is very high. So even your very technical people can start doing really crazy stuff in there. And you can, if you have like an enterprise, for example, you might have one site that's particularly innovative. They came up with a really great, I don't know, Kanban tool or something, or they came up with a really great cycle counting for inventory using SAP. Well, just put it on your app exchange and then let everyone else use it. So it's pretty great.
And I think this is this use case is great because it's real. So many times I feel like people on the technology side of things, they want to like cherry pick these laboratory environments in which literally one piece of technology is the answer to the question, but it's never the case. Like in this case, what did we want to do? We wanted to make sure that press was running, but you couldn't understand that where the problem was without first getting into the OEE data. Great, but then you quickly realize that you're actually talking about a material handling problem here, and then you solve that, but then you're going to start moving into the next point here. So again, I actually think, Walker, I think did you call it a quilt or something? A quilt, yeah, but it's a perfect framing.
I say tapestry. Tapestry. I think it sounds cooler. I don't know.
Yeah. Whether you call it a quilt or a tapestry, but the point is, all this stuff is interconnected, and you can't really separate it. And so for me, I think what that drives is like, what sort of fundamental technology and architecture decisions are you going to make to be able to embrace this complex, kind of ever-evolving, dynamic environment, while giving the people who actually know where the problems are and actually know how to solve those problems the ability to do so. And I think that, I don't know, props to the ProveIt team, because you guys, man, you nailed it. I mean, I don't know, we're up here, but it was a great challenge.
Mark nailed it.
Yeah, wow.
Mark, you're gonna get a lot of visitors, brother.
Appreciate that. This has been really fun. It's awesome how well this is put on and all. So thank you, everyone, for hosting us. And yeah, that's sweet. I guess we'll talk about questions. But this is the library, by the way. If you haven't seen the library, this is all.
Come to the booth. We'll show you all this
okay.
stuff. Let's do questions.
Yeah. Can we get the QR code up there so we can have the audience submit questions? While they're doing that, I want to ask you the classic MC question we're asking everybody. So what you just showed was honestly really incredible. I can't believe how much you got done in so little time. But let's anchor your solution, as Jeff would say. In your opinion, what is the best alternative way to accomplish what you just did, and why is yours better? You don't have to knock any specific software, just what would be your approach if you didn't have Tulip?
Yeah, I think, look, the key point here is open architecture and open ecosystem, like fundamental day zero decisions, right? And then within that, the question is, well, what's the problem you're trying to solve? And if you're solving a problem that's around how are you getting information and driving interaction with human beings and bringing humans into the unified namespace concept, we're really good at that, right? But if you're solving a purely, if we're talking to a Coca-Cola bottle filling station, well, the same principles apply, but we're probably not the solution you want to go to. So it's really, I think, more a matter of there's some right answers in terms of architecture and first principles, and then it's a matter of picking the right tool for the right job. I
would say that that particular problem, if that's the problem you're solving, then the right solution would probably, the best solution possible would probably be a programmer writes something awesome for that problem. But that's not the problem you're solving. You're actually solving the capability of the people who know manufacturing to solve their own problems. So it's it's not really the problem you're solving. You actually want to make it, because the environment's going to change over time. Mm-hmm. Even Walker was saying that this customer, they've been a customer of yours for, your son's working there. He's been there for years. So So they're still supporting them, you know? But the problem that we want to solve is the industrial base needs to be able to use technology without being a programmer, you know? Stop using Excel. So, yeah,
your distinguishing
that's my take.
feature is the low code with ability to do more advanced if you need to, right?
Yeah.
To enable the frontline people to do it
Yeah, you should be able to
themselves.
solve your own problems as the people who know it best. Because otherwise, you're outsourcing it. You have to communicate that problem. And by the time you've communicated it effectively, it may have changed. And you really need to find those Walker types who get it and can build it quickly and then support you. Otherwise, I don't know what you would do to solve it. You're going to use Excel, probably.
Yeah.
Awesome. All right, let's ask another question. So I've actually heard this one a lot. So what are the advantages to building apps in Tulip versus Ignition?
You want to take it?
So I have heard a lot about Ignition, mostly through Walker. And I can say that I'm not an expert in it by any means, but I do want to play with it. It looks really cool. Michael Walker was showing it to me over there, and I was showing him this, and we were like, that's cool about yours, and that's cool about yours. So it's definitely it's a great system. I think I want to learn more about it, but the bar is much higher with Ignition to even start playing with it. There's a lot, and then the whole module thing, you have to like pay for the modules. I'm not sure what's going on with that. And then, so I'm not like an expert, but you guys probably know about it. You know,
I would also say that we integrate with Ignition a lot. So it goes back to that right tool for the right job, and they're different tools. And I think when I think about more SCADA, MES type, pure machine monitoring type use cases, you know, I see Ignition a lot. And frankly, it's pretty good if you want to connect to a unified namespace with 1,000 assets that are outputting data in real time. You've got a few different ways to do that, and Ignition is one of them, right? So if you want to hardwire all that stuff into Tulip, you can do it. But it might not be the right architectural decision. You know, we'd want to have a conversation.
The answer
about
I
that.
generally give is Tulip is an operations platform.
Yeah.
It's meant to be in the hands of citizen developers who are operators under a common digital strategy in the organization. To Mark's point, you're not generally going to give an Ignition designer to an operator to build their own solution.
Yeah.
You might give it to the electrician to build a solution. Literally an electrician can build an Ignition, but operators can build in Tulip. And so the way that we architect is Tulip on the edge, operations platform, Ignition L2. So L1 becomes Tulip, but now they're natively integrated on common infrastructure. So that's the answer I give.
Another thing I saw with Walker is in a lot of your solutions, you end up building a whole set of views to configure what you built.
Correct.
And then in Tulip, it is the configuration. So you're the one doing the building. You know what I mean? So it's kind of you're just letting people have access to this technology without having to learn, without this learning curve of. I mean, it's powerful.
It's not either or. It's both, and in a different spot in the organization.
Yeah.
And it's interesting. The next question is, well, how does it compare to Power Apps? And it's
Yeah.
like, well, that's okay.
Yeah, it's totally other. For Power Apps, I mean, look, in the early days of Tulip, all the time we get asked about all the horizontal no-code platforms. You know, how is Tulip different? And the answer is, from day one, Tulip has been laser focused on frontline operations, and frontline operations are unique. They're different than other environments like financial services or call center optimization or you fill in the blank, right? In a lot of really important ways. And the first is that manufacturing operations exist in a physical environment. So there's a whole edge connectivity stack in Tulip that you need because you've got not just software running on a screen, but you've got software running and interacting with physical equipment, whether that be something simple like a barcode scan, or whether that be something a little bit more complex, like lots of different attributes coming off of equipment in your environment that's going to inform the kind of software you want to build, how you want to deploy it, and what kind of decisions you're going to make once you have that insight surfaced and routed to the right person. And again, so it's the physical connectivity side, it's the back-end connectivity side, and then also, again, Tulip is no code with the option to go low code, whereas a lot of the, like Power Apps, or I would add to that, Mendix, for example, we get a lot. It's really designed for more of like an IT type of persona.
The Power Apps, you just can't even connect. It's not made for manufacturing, and it shows. I mean, you can do stuff that's workflow related, and that's cool. You can do back office stuff. But if I have a device at my work center and I want to turn lights on or do anything physical, then Power Apps is just not going to do it.
And the next one is pretty easy. This is basically any device that's running the
Oh,
software.
you want to read the question? Just so-
Yeah, so what counts as a $250, what counts as an interface? Basically, any physical device that allows you to interface with an application is an interface. It could be a dashboard, it could be a cell phone, it could be a tablet, it could be a touch screen, it could be an HMI on a device. So all of that would count as an interface. And by the way, it's worth pointing out, we try and be transparent. So if you go to our website, you'll see pricing, and that's what Mark put out, answered these questions with. But the reality is, we don't usually sell 10 interfaces. Usually people say, hey, I want to bring this capability into my company, and it's a conversation around what's the total scope of that, and it's all basically enterprise types of discussions around that.
Another thing I like about it is if you are counting stations and all that, and that's like how you purchase Tulip. It's not like we stop you from innovating. You can, and that's what I love it about it, is that you can just, if you have an idea, you want to try something on these stations, and then just do it, you know? And if it works, I mean, we'll catch up later and you'll pay for that. You'll be happy to pay for it because it solves something, you know? So just build, just try and solve problems.
Yeah, but it's an important point. So we're not gating how many engineers or operators or users or analytics or reports or connectors or apps can be developed or automations can be developed and run on Tulip. All that, sky's the limit, go nuts. The idea here is we want to basically make it free and easy to identify ways to create value on the shop floor. If you start using it, no problem. If you continue to use it, well, that's when you would pay for it, right?
All right, so another question. Should we consider using Tulip exclusively for traditional MES functionality and more?
That's a great one.
Or is it that we think we still need a separate MES system?
Yeah, this is like more existential than the person asking the question maybe realized. What is an MES specifically? And then followed by it depends, right? Tulip is a platform, and our most common set of use cases deployed together as a tapestry or a quilt, or you pick your metaphor, it comprises MES functionality in most cases. And in many, many cases, Tulip is the standalone MES in these facilities. We win, MES RFPs all day long. Not all of them, by the way, but we win MES business all day long, and it's great business. Because intrinsic to the definition of MES is like, it's got a broad and sort of expansive set of interconnected functionality, and so people have a pretty good mental model for what it is that's well aligned with the way that we are characterizing the Tulip platform. But you still may need, if you think about more of like SCADA level, machine monitoring, or like a fully automated operation is still going to need an MES. Well, that's not Tulip, to Walker's point earlier. We should get you up on stage for this.
He has a microphone. All right.
He's basically on stage.
That's true. That's true.
I'll say the answer to that question is actually, it's to your point. MES is not a thing, okay? It depends on who you're talking to, what MES is. So not the opinion, the end user. Because MES, there's the core 4, and then there's a suite of other hundreds and hundreds of possible functionalities. To answer your question, for some of those functionalities, the answer to that question is yes. For some of those functionalities, the answer is maybe, and for some of those functionalities, the answer is no. So in order to answer that question for you, it has to be a conversation. Yeah. Because it's either going to be yes Tulip and something else, or no Tulip and something else. And
when we deploy, people will come in, they'll say, hey, I heard about Tulip, I want Tulip. And we'll say, great, what do you want to do with it? And they'll say, well, I've got an MES, but I'm not ready to rip it out. And we're like, yeah, why would you do that? If it's like working, why would you change it? We'll basically attach to and extend that existing MES. Sometimes they'll say, I don't have an MES, but I need one. And we'll say, why do you need it? Let's talk about that. Let's not talk about the functionality you need. Let's talk about why you need it. And then let's start to think about what the scope of this thing is going to look like. And sometimes they're going to say, look, I know that I'm going to have to replace this in a couple of years. I don't want to pay the upgrade fee, and I want to start to migrate functionality off of it, and that's all good. We'll do that all day. Okay, is this solely on-premise, or is there a cloud element to this? It is hybrid architecture, but fully cloud native. So everything you're seeing here is running. The whole backend is running on AWS or Azure. We're cloud agnostic. We do have, as I was alluding to earlier, a full edge stack. So when you think about the applications that you're seeing Mark run through up here on screen, those are executing locally on the client, leveraging like the CPU on the device. We also have an edge stack that can run locally on the either on the network or one of our edge devices, and we're fairly agnostic as far as that's concerned. That's largely for performance and reliability concerns, but the core of our platform is cloud native.
So the follow-up question, can you use it exclusively on-premise, or is it hybrid?
No is the answer today. A few years ago, the answer was sure, but are you sure you want to? Then everybody stopped wanting to run it on-premise entirely, so we discontinued it. And now aerospace and defense is knocking more and more, so stay tuned, more to come.
All right.
So in regards to life sciences, what would a batch report look like? Well, that's an interesting question. We can show. I don't have an example to show you.
Actually, they have a great demo. They have a great demo on this one. So
yeah, we have some examples of like what you can obviously do paper on glass, and you can have this long list of things, and that's fine too. But we have some in our experience centers, and some of our customers are thinking about it more of like an interactive thing. Like, what are you trying to get from the batch record? Are you trying to do approvals on it? Do you only want to do managed by exceptions and this sort of thing? So it's kind of like, why do you want to see the batch? It's all there. Every time someone touches anything, it's there. You can look at it and audit it, and it's not going anywhere. It's a question of what workflow, what are you trying to do with the thing, and who's trying to use it, and that's how you can kind of present it and display it.
In about half of our businesses in life sciences, EBR is the EDHR. So if you think about pure biopharma, or cell and gene therapy, EBR is our primary use case for that environment, which is kind of interesting. It's like MES in a lot of ways because the electronic batch record is the log of every interaction you had along the process. Well, how are you going to get that log if you don't have a presence at every step along the process, right? So it's this mosaic or tapestry or quilt of use cases that come together. The EBR is just the reporting side of that. But you have the same thing for regulated, whether it be CFR 21 Part 11 life sciences environments, so like a pacemaker or a cardiac catheter or something like this, or aerospace and defense. It's like the regulation right next door, all the same requirements. They even call it EDHR, but that's our primary sort of land. The way we talk about MES to general discrete, we're talking about EDHR and EBR for life sciences, or increasingly aerospace and defense.
And I'll answer the next one just to make it easy. How do you choose what goes in UNS and what comes directly from a SQL query? UNS is structure and current state. So it's an architecture that is structure and current state. So every event, every data model, and every information model goes in the UNS. So the data store for all of the transactions that are in a SQL table, they don't go in the UNS, but the result set from a request is something you would put in a unified namespace, and it's ethereal. So it would return into a UNS, and then it would disappear the next time the next query comes. So there are lots of direct SQL queries that come from a database to, say, Tulip or some other application, but the fact that event happened, that the request was made and the result was returned, that's something that lives in the UNS so that other consumers know that it happened.
So when I was making this thing, I did think to myself, well, what do I want to put in the UNS? And I had a couple of things that I decided to put in there, or keep in there, or use the UNS4 versus the SQL database, which is just like a ledger of all material requests is in the database. But anything that was event-driven, like if I had a shortage and I wanted to let this other person know and do something about it immediately, that went through the UNS. Or if I had information that I thought might be useful to someone else in an imaginary future state, I put it there too. So if I thought you might care, who was the material handler? Well, that's in the UNS. Or you might care, what's the average lead time? I could put like an analytic in there, So you don't have to calculate it somewhere. Like if someone's saying, what's the lead time? I don't want them to have to go find it from some place. Just go to the UNS, it's there, that's how long it took. That's how long it takes now. And you can chart that and see if it's getting better or worse or whatever. So that was how I decided what should go in the UNS for this.
That's the right way, man.
It says we're out of time, but I got to answer at least one more, and I don't know how time really works here. Is the hook coming out? Is this the music? One more. Look, so the question here is, do we offer training licenses or some way to get good at the platform? The answer is, look, go to Tulip University. All this stuff is free. You can take courses that'll teach you how to use the platform, that'll teach you how to identify use cases, that'll teach you how to think about your data model, how to integrate with different backend systems. All this stuff is free at tulipuniversity.co, and you can just get a free trial license. If you're just tinkering in there, shoot us an email, and we can figure it out. If we start seeing you tinkering in there and then deploying hundreds of different interfaces to the production environment, I might call you.
Join office hours too. Those are free.
Yeah, office hours are free.
Wow.
Thank you all.
Final
All right, guys,
round of
thanks.
applause for Tulip, everyone. Thank you, guys. That was wonderful.